Alright, this is Math 141, Fall Quarter, 2024, Highline College. My name is Thor Johansson. I'm your math teacher. And these numbers here are for each of the sections in chapters 1 and 2. And what these correspond to are the questions you'll find in WebAssign. So when you look at section 1.8, WebAssign assignment, the first question is similar to question 14 in your textbook. The second question is similar to question 41 in your textbook. The third question on your WebAssign 1.8 homework is similar to 42, and so on. And I have these in order, and what I'm going to do is I'm going to do these questions for you, and what I recommend you do is when you pull up a video, you look at one question at a time, and after you look at each question, you try and do the question on WebAssign, and it should be very similar, and it should help you in completing the homework. Alright, in section 1.8, we've got 4 different things that we're worrying about. First one is to solve a linear inequality. There's only one question of that type, question 14. And you first solve for x, isolate x, and then if you have to multiply or divide by a negative number, you must flip the inequality sign. Okay, so let's look at question 14. You got minus 4x is greater than or equal to 10. So in order to solve this for x, you need to divide by negative 4. Now we just divided by a negative, so you must flip the inequality sign to the other direction. Now you've got this 10/4 reduces to 5/2, negative 5/2. And so here's my inequality from minus infinity to minus 5/2 bracket, meaning I'm including that endpoint because we have equality there. And we've got the number line from negative 2.5 and to the left to negative infinity. The next type of problem, there's quite a few of them, of these numbers here, is solving a quadratic inequality. This is a little harder. We're going to set it equal to 0, and then we're going to factor. Then we're going to set each factor equal to 0 and solve. And these answers that we get, we will use to divide up the number line. Then within each region that we just now created, we're going to check a test value in the inequality. And all we care about is the sign of our answer. We don't care about the actual answer, just positive or negative. And then we finally choose which region we want based on the original problem. Alright, so 41, we've got this inequality. It's already set to 0. So we factor it, factors to these two terms. Then you set each factor equal to 0. And when you solve x minus 6 equals 0, you get x equals 6. This one gives you x equals negative 3. And like I said, you divide up the number line to minus 3, and 6 will help you to divide it up. So now you got 3 regions. Now we're going to pick a number in this region, possibly negative 4. We're going to plug it into the inequality. Remember, plug it into where it's set to 0. So you got to use this one or that one. This one's easier. So minus 4 minus 6 is minus 10, negative. Minus 4 plus 3 is minus 1, negative. Negative times negative is positive. So there we go, we got a positive there. Now, between minus 3 and 6, we can try 0. Plugging in 0 here, you get negative 6. Plugging in 0 here, you get 3. A negative times a positive is negative. And then we can try 7. Could even try 10. Let's try 10. 10 minus 6 is 4, positive. 10 plus 3 is 13, positive. Positive times positive is positive. So now we put a plus sign there. Now what are we looking for? We're looking for answers that are less than or equal to 0. Well, we know they're equal to 0 at the endpoints, and less than 0 would be negative. So we're including these endpoints and everything in between. So here's our interval with brackets, and here's our number line. Okay, now 42, same idea. It's already set to 0. You factor. Set each factor equal to 0. You get your two numbers. You use those numbers to divide up the number line. Now notice I put a hollow circle there because we don't have equality. We're not going to be including these endpoints. Alright, so I'm going to check a number in each region. Over here we can pick 0. 0 minus 1 is negative. 0 minus 7 is negative. Negative times negative is positive. Between 1 and 7, let's try 2. 2 minus 1 is 1. 2 minus 7 is negative 5. 1 times negative 5 is negative. And let's try 8 for this guy. 8 minus 1 is positive 7. 8 minus 7 is positive 1. Multiplied together gives you a positive. So now what do we want? We want greater than 0. So we want the first and third regions. We're not including the endpoints. So minus infinity to 1, not including 1. And greater than 7 to infinity. And you have to use a union symbol there. Okay? And so we're also looking at that number line right there. 43. Okay, it's not set to 0 yet, so you got to subtract 2. Now it is. Factor it. We do. Set each one equal to 0, and you get your two numbers, 1/3 and negative 2. Helps you divide up your number line. And now I check a region in each one of these spots, and I get my signs. Now what do I want? I want greater than 0. So I want the positives. I want the first and third regions. And I also want the endpoints because we have equal to 0 as well. So minus infinity to minus 2 bracket, union, bracket 1/3 to infinity. And number 45, we bring everything to one side, factor, set each factor equal to 0, solve, use those numbers to divide up your number line, check a region in each check a number in each region, and what do we want? We want less than 0, so we want the negatives. So we're choosing between minus 1 and 4. Notice we're not including the endpoints because we don't have equal to 0 here. We just have less than 0. (49) Same idea. Bring the 4 over, factor, set each factor to 0, solve, divide up your number line. Check a value in each region. We want negatives, so we're picking the middle region here, and there's our answer. 53, this one's already factored, so you said x minus 4 equal to 0, and if you let x plus 2 squared equal 0, you just take the square root and you get x plus 2 equals 0, which will give you negative 2, this one will give you 4. So whether this one is squared here or not, you're still going to get only one answer with this parentheses of negative 2. So you divide up your number line, check each region. Notice this one's a little unusual. It doesn't go alternating. This one actually has a minus and then a minus and a plus. Typically it alternates. Alright, and so now we're looking at things at less than 0. So we're including the first and second region. We're not including the endpoints. (56), it's already factored, set each factor equal to 0. You get 3 numbers here, so you have 4 regions to check. You check them, you're looking for less than 0, negatives, and you're also looking for equal to 0. So from minus 3 all the way to positive 3. You don't have to stop at 0 because we're including everything in between, and we're including all the endpoints, so that's basically minus 3 to 3. There's no need to say minus 3 to 0 and 0 to 3. Just say minus 3 to 3. Alright, 57, you factor. Set each factor equal to 0. You get 3 numbers. Divides up your number line into 4 regions. You check your regions for signs, and we're looking for positive, so we want region 2 and 4. We do not want the endpoints. Alright, another type of problem we're about to look at is fractional inequalities. Now a fractional inequality is something where it's obviously a fraction, and you set it equal to 0, meaning throw everything to one side. Then you write it as one fraction. What do I mean by that? I mean get a common denominator and bring it together as one big fraction. You set the numerator equal to 0, set the denominator equal to 0, and you solve. These numbers will divide up your number line like before. You'll check a test value in each region, and you choose the proper region. The only difference here is you got to watch out for division by 0. So whatever number you get for the denominator equal to 0, you've got to throw that out of your answer because that would be dividing by 0, and that creates an undefined answer. Alright, so this one, it's already set to 0. So we set the numerator equal to 0, the denominator equal to 0. We solve each one, and we get these two numbers. Divides up our number line. And again, we do the same thing as before. We check a number in this region, probably minus 2 would be good. Minus 2 minus 3 is minus 5, negative. Minus 2 plus 1 is negative 1, negative. Negative over negative is positive. What about 0? 0 minus 3 is negative 3. 0 plus 1 is positive 1. Well, negative over positive is negative. And then do the same thing for this one with maybe 4 or 5. Plug it in there and you'll get a positive. Now what do we want? We want equal to 0 or positive. So we want regions 1 and 3. And we want to include the endpoints except this endpoint minus 1. You want to exclude that one. So notice we're including the 3. But we're not including the minus 1 because that's division by 0. 65, you bring the minus 3 over. And now you've got two numbers. You got to write this as one big fraction, so you got to get a common denominator. If you write 3 as 3 over 1, then I multiply top and bottom by x minus 5, so they both have the same denominator of x minus 5. You get this. Notice you got minus 3 times x, and minus 3 times minus 5 gives you plus 15, positive 15. And you combine and you get this. Now you set each denominator and numerator equal to 0. Divide up your number line. Check each region. And you're excluding where your division by 0, so you're excluding the 5. And we want less than 0 or equal to 0. So less than 0 is regions 1 and 3. Equal to 0 is just the 16, not the 5. 5 is division by 0, undefined. So we're including minus infinity to 5. We got minus infinity to 5, not including 5. And we got including 16 all the way to infinity. And there's my number line. 67, same idea. Bring this guy over here. And now, if you write x as x over 1 times x over x, you get a common denominator of x. So now you can add them. You bring them together. And you set each one equal to 0. Factor. And you get three numbers. You divide up your number line. Check each region. And you want negatives. So you want regions 2 and 4. And you're not going to include 0. So you throw out the 0. And you throw out the other two as well because you don't have equal to 0 here. Alright, 69. You throw everything to one side, and this one's a little more complicated because you've got this one is just 1. This one's 2 over x plus 1 and 2 over x. So my common denominator is x times x plus 1. So you multiply this one top and bottom by that. You multiply this one by just x over x, and you multiply this one by x plus 1 over x plus 1. Now, they all three have the same denominator of x plus 1. Multiplying all this together, you get the first two terms. Multiplying those together, you get this term. Multiplying those together with a negative 2, you get these two terms. Notice it's negative 2 times x and negative 2 times positive 1. That gives you a negative 2. Bring everything together. Set them equal to 0, solve, you get 5 regions. And we're looking for equal to 0 or negative. So we're looking at regions 2 and 4. But we're not going to include 0 and minus 1 because that's where you're dividing by 0. So we're going to include the negative 2 and the positive 1, but we're not including the other two. And so there's our answer. And 71 is the same idea. Throw everything to one side, common denominator, set numerator denominator equal to 0, solve. That's nothing new there. 74 is absolute value. When you have absolute values less than c, you write minus c is less than x is less than c. So minus 8 is less than or equal to x is less than or equal to 8. And so when you solve this, you get this answer, and there's your solution right there.